Hi, my name is Jesslene, and this video is how to solve compound inequalities. So we're going to talk about those first. So first of all, let's just do vocabulary. A compound inequality, it consists of two inequalities, and they are connected by the word and, or they're connected by the word or. And for example, it means this or this and this, so they're both included in the solution set, so you're looking for how they overlap. On the or, it could be either that inequality or the other one, so you have to include both solutions on the solution set. So for example, for an and one, it could look like this. You could see it like that. And that stands for 0 is less than or equal to x is less than or equal to 4. So basically, my solution set is anything between 0 and 4, and including 0 and 4, because these are or equal to. So when I graph that, I graph it on a number line, and I have 0, then 1, 2, 3, 4, 1, 2, 3, oh, I don't even need that. I have 1, 2, 3, 4 because it's between 0 and 4. If you need a refresher on how to graph inequalities, go back and watch that video of graphing inequalities. So 0, it's going to be a closed dot, so a closed dot on 0, and then a closed dot on 4. And with and, we are graphing the overlap, so it's what's in between, so x is in between 0 and 4, so we graph it like that. It can also be written like this: x is greater than or equal to 0 and x is less than or equal to 4. And in this case, if it's written like that, you can graph them both on the number line. This is how I do it. So here's 0. X is greater than or equal to 0. I graph above the number line, and I just do a point. X is greater than or equal to 0 is closed dot shaded to the right because it's greater than. And then 4, so 1, 2, 3, 4, here's 4. X is less than or equal to 4. So it's a closed dot, but it's shaded to the left. And then you can see, oh, well, here is where everything overlaps. So that's what I graph on my solution. I overlap it, and I graph it like that. Okay, so if it's written like that, you can graph them and then look for the overlap there. Okay, so that's how you graph an and. Now, let's talk about solving an and one. Solving an and one. So if you have -2 is less than 3x minus 8 is less than or equal to 10. So when you solve it, an and, then you can split it up into two problems. So I'm going to split it up. -2 is less than 3x minus 8 is my first one. And then my second one is the middle term is going to be included both times. My second one is 3x minus 8 is less than or equal to 10. So now I have two inequalities that I'm going to solve, okay? Two inequalities I'm going to solve. Over here, add 8, applied for solving inequalities video. Go watch that if you need a refresher. So add 8, 6 is less than 3x. And then we're going to divide both sides by 3. Divide both sides by 3. 2 is less than x. And then we have to solve this one. So solve. Divide by 3, x is less than or equal to 6. Okay, so the important part is knowing how to split it up and solve it, because you should already know how to solve inequalities at this point. Remember, math builds on itself, so you have to remember how to solve inequalities. So now I know if I see it, I can rewrite the inequality as a and. So 2 less than x, x is greater than or equal to -6 is greater than or equal to -6. So that's how I draw it. I think I have room to draw the number line here. Since it's written like this, I know it's going to be between 2 and 6. So here's 0, 1, 2, 3, 4, 5, 6. It's an open circle on 2 because it doesn't have an or equal to, and a closed circle on 6, and then we shade in between because it's an and. Shade in between. So that's how you graph it. Okay, that's how you graph and inequalities. Now let's talk about or. Yeah, let's talk about the or ones. So for an or inequality, you're going to have two inequalities written. X is less than -1, or, and you'll have the word or X is greater than 2. And so when you look at this, you want to graph them on the same number line, and you graph them both. You don't look for the overlap like you did for and, you just graph them on the same number line. So on my number line, I have 0, -1, so I'm going to graph this one first. So -1 is an open circle because there's not an or equal to. Open circle and less than, so less than shades to the left because everything less than -1. So I just shade it like that. And then we have 2, so 1, 2. It is a open circle as well because it's not or equal to, and X is greater than 2. So we're shading to the right, X is greater than 2. And this is my solution set, okay? And that's how you graph it. We didn't look for the overlap or anything. If this was an and they don't overlap, that would be no solution, okay? But since it's not an and it's an or, we graph it like this, okay? So X can be anything lower than -1 and higher than 2. Does not include -1 or 2 though. Another example, now to solve an or problem, 3x plus 1 is less than 4, or 2x minus 5 is less than or equal to 7. Okay, so for this one, all we do is solve these inequalities like normal. So we have 3x plus 1 is less than 4. We're just going to solve this inequality. Subtract 1 from both sides, we get 3x is less than 3. Then we're going to divide both sides by 3. X is less than 1. Okay, and then on over here, 2x minus 5 is greater than or equal to 7. Add 5 to both sides. 2x is greater than or equal to 12. Divide by 2. X is greater than or equal to 6. So remember, this is an or. So we're going to take them and we're going to graph them both on one number line. So in this one, x is less than 1. So here's my 1. Open circle, x is less than 1. We're going to shade to the left because less than. Then over here, x is greater than 6. 2, 3, 4, 5, 6. And it's a closed circle because it has an or equal to. And then greater than 6, we shade to the right. Okay. Now for an example, it is sometimes where, let's say, I'm just giving you an example. Let's say when we solved this, it was x is less than or equal to 6. So 1, 2, 3, 4, 5, 6. Here's 6. Here we go. And x is less than or equal to 6 would shade to the left. Now covering that 1 because that includes that one. And so it would be just 6 shaded to the left that way. So you have to kind of think about it in all different types of situations. I can't show you every situation, but you solve them all the same way. And that's how you do compound inequalities. Thank you for watching.